Have a good day and Happy New Year! Welcome to our topic, which entitled the holography. I know that all of you are not yet familiar of what is holography, but keep on watching because we will dig deeper to our topic for you to know.
To further understand what holography is, first, let's dive into its history. Where did it came from? Who invented it? How? And so on. These questions are essential as a starting point in knowing more about holography. So holography was invented in 1947 by Hungarian physicist Denis Gabor, work for which he received the Nobel Prize in Physics in 1971. So Gabor's research focused on electric optics, which led him to the invention of holography. The basic idea was that for perfect optical imaging, the total of all the information has to be used, not only the amplitude of optical imaging, but also the phase. A complete holospatial picture can be obtained. At the time Gabor developed holography, coherent light sources were not available, so the theory had to wait more than a decade until its first practical applications were realized, though experimented with a heavily filtered mercury arc light source. The invention in 1960 of the laser, the first coherent light source, was followed by the first hologram in 1963, after which holography became commercially available. So, what really is holography all about? Holography is a technique that allows light scattered from an object to be recorded and later reconstructed so that it appears as if the object is in the same position relative to the recording medium as it was when recorded. So the image changes as the position and orientation of the viewing system changes in exactly the same way as if the object was still present, thus making the recorded image or hologram appear three-dimensional. Holograms can also be made using other types of waves. As you can see in the presentation, the timeline of holography is being shown. We can actually see the progress that have made by the inventor and other people involved in the making process throughout the years. In 1947, Denis Gabor developed the theory of holography. In 1960, the pulsed-Robe laser was developed. In 1962, white light reflection hologram. In 1983, MasterCard first credit card to use holograms. In 2009, interactive holographic displays developed, and up until 2010, when the development of moving 3D holograms happened. Now,
a company, Burton, developed this laser plasma holographic device, a true 3D display, which can produce bright dots in the air, so the audience can see 3D images in real 3D space.
How hologram works. The time-varying light field of a scene with all its physical properties is to be recorded and then regenerated. Hence, the working of holography is divided into two phases, which are recording and reconstruction. What do we mean by this? Recording of hologram. Basic tool required to make hologram includes red lenses, beam splitter, mirrors, and holographic film. Holograms are recorded in dark environment. For example, Paper's Ghost, the aerial Botron laser, light field display, digital holographic tabletop, and physical holograms. Reconstruction of hologram. The reconstruction process the hologram is illuminated by laser beam, and this beam is called reconstruction beam. This beam is identical to the reference beam used in construction of hologram. The reconstruction beam, after passing through the hologram, produces real as well as virtual image of the object.
Process of hologram. When hologram is made, light from laser records an image of the desired object on film or a photographic plate. During the recording process, object wave and the reference wave interfere in the plane of recording medium and produce interference fringes. These interference fringes contains all the information about the intensity and the pace of the scattered beam from the object.
Hologram properties. If you look at these holograms from different angles, you see objects from different perspectives, just like you would if you were looking at a real object. They usually just look like sparkly pictures or smears of color. If you cut one in half, each half contains whole views of the entire holographic.
I'm the one to discuss about the basic holography equation. I will show you the example of holography equation. The holographic method is a technique that enables a wavefront to be recorded and later reconstructed. A hologram is made by superimposing a second wavefront, or normally called the reference beam, on the wavefront of interest, thereby generating an interference pattern which is recorded on a physical medium. The holographic principle states the entropy of ordinary mass, or not just black holes, is also proportional to surface area and not volume. That volume itself is illusory and the universe is really a hologram, which is isomorphic to the information or inscribed on the surface of its boundary. And now, the application of hologram. First, entertainment, virtual communication, simulation and planning military, space application. The application of hologram is the teaching and training one-on-one with virtual holographic images, sports, technique coaching and training. The virtual communication record yourself for future great-grandchildren, virtual sales presentation, corporate meetings, video travel, the presidential, the planning and simulation, disaster planning, traffic, transportation. Next, the holography in everyday life. A telephone credit card used in Europe has in both surface holograms which carry a monetary value. When the card is inserted into the telephone, a card reader discerns the amount due and deducts, or erases, the appropriate amount to cover the cost of the call. And now, the holography of the future. Perhaps the most anticipated is the development of a television with 3D technology without the need for glasses. Nowadays, mobile phone video conferencing has left the Star Wars holographic system outdated for messaging. Other applications of holography that are coming include the creation of personal holograms or the development of aerial